Okay. We need to do it in the lamina hood. Tak on. Okay. You need to switch on the blower. So blower from the back. Okay. Do this near the flame. This is the empty. Actually, this is the empty or blank media. You see, the blank media have the light yellow color. Okay. And then this is your inoculum, where we already grow the bacteria. We take one loop full and we culture for overnight. Okay, you see the comparison. This is the blank media without anything. So when the bacteria growing, so it will change the color of the media into the milky, yellow milky color. Okay. So what we did first is, so this one is 90 ml. Because we want to do the 10%. So this is around 120 ml media. So this is 10%. Firstly, you flame the shake flask first. Put it near. Okay. Since this is 120, so we need to have the inoculum 10%, which is around 12 ml. So using the pipette, okay, near the flame, you pipette around 12 ml or equivalent to 10% of the inoculum inside the shake flask. Okay, and then this one. Okay, simulating, and put it flame and cap it with the aluminum foil. Then directly transfer to the incubator shaker. Okay, the operation condition for the incubator shaker is 35 degree, 150 meters. Okay, and it's actually for the pH, we already adjust the initial pH. Yeah. So this is the incubator shaker. Okay, put this one into this. Okay, and then close it. Put it stop. Okay, start button. And tak nampak sangat. So here we already set 150 and 35 degrees C. So we let it grow for a while. Every 30 minutes we stop the incubator, open this one, take the shake flask and go to the aluminum hood to take the sample. Itu juga.
Okay, so I want to show you this how prepare the seed culture for the fermentation. And then before we start, I think this make sure all this laminar flow. We want to make sure there is no contamination inside in the laminar flow. So I think this we have some what do you call this what do you call? Then we want to protect to avoid, because lavino is coming from the front. And then we have the 100 ml, the what we call this inoculum. We need to transfer into the inoculum transfer line, and then the containing but this media actually is 100 ml, and then our bioreactor is size 1 liter, and then you can put is maybe 1.5 liters, and then I try to show you how we can transfer, make sure there is the contamination. So actually this inoculum flask we have autoclave. So I think you know this how we can autoclave this. This one the temperature is 121 for 15 minutes, and then I try to open slightly and then make sure there is no contamination. Okay, so this one make sure I cannot talk too much. Actually, this I want to avoid this from my mouth that release some, you know, the organism. So okay, so try to slow open this aluminium. Okay. Okay, I try to transfer this slowly.
Do it near the food. Why we do it in the near the flame? Because we want to avoid the contamination, cross contamination, and we transfer it to another glass.
Okay, we finish. So I think this we want to bring this inoculum into bioreactor. Cut. Okay. Now I try to open this the tubing. Do have the connector? We call the connector. Okay, alright. Make sure there is no some organism surrounding here, but you need to open slowly. Okay, don't worry because they have some rubber inside the connector. This one they're very tough. Okay. Okay, this one there is some rubber here. Don't worry about this. They have some rubber. Yeah. Okay, so we have connected already, and then make sure there is no pressure inside the bioreactor because if you have the pressure, it's very difficult to bring inside this our inoculum. So I stop here first, right? Okay, there is no pressure. Make sure there is no pressure. Espaging inside. Then we try to transfer it. Yeah, then we open this clip. You see some bubble inside. There is a pressure. I told you. Okay, now we try to press this TV. Make sure now if you have the slowly because there's a pressure. So maybe we try to click slowly. Yeah. Make sure that some the seed goes inside the bioreactor slowly. There is a pressure. It's okay, almost complete.
You can see that the color of the media changing. Previously is quite light yellow, and then because there is some glowing, we put the inoculum in the glowing bacteria inside to become a bit cloudy. Okay, we need to off the clip the tube line.
Okay, we try to open again this connector. Okay, don't. Okay, so make sure this what do you call? this connector, there is no, there's because sometimes the microbes are still there, and then after this you want to make sure before you wash, and then you need to autoclave first, right? So after you autoclave, similar is like others, and then you need to what do you call the clean, and then you can put in the dryer. Okay, so we almost complete, and then I want to have some, you know, the tissue, please. And then I try to open again this what you call it, the espaging, right? Make sure some, you know, the oxygen comes into the bioreactor. So I think we want to show you how is it, maybe what is the requirement, what is the requirement of the oxygen, because some bacteria we call this aerobic and facultative aerobic. So we need to know about this. So we, after this, we control the setting condition, the temperature maybe 35 degrees C, the pH 7.4, and then the partial oxygen pressure is around 20%. I think after this, maybe Brother Anwar and Dr. Sakina will explain to you. Okay, so maybe I will ask because the all right. Okay, now this I try to show you how we can operate this bioreactor. Actually, the bioreactor is the size of this bigger than the shake flask, and then after we have the seed culture, and then we are growing this the E.coli and bioreactor. You can see there is some, you know, there's the growing E.coli inside the bioreactor. Maybe from the light one it become viscous. You can see about this maybe density, and then we need to check. We want to check this one maybe in terms of growing. We try to take our sample. Maybe not now. Maybe we take this 10 ml, and then we put it in OD. In the wavelength is maybe 610 or 610 nanometer. We come to the UV, and then we can see the OD is maybe OD 0.5, 1, 1.5, depends what we call this, the density of the culture. But now, in bioreactor is very good. So we want to find a good condition for the you know, the cell, the E.coli. Make sure condition is suitable for the E.coli growing. So normally we practice in our lab. Normally we want to set around 35 degrees C. You can see now, because now because 37, right? Because they're just heating, the cooling system, they're still adjusting. Because this one 37. Normally they try to put condition about the 35 or 37. So now they set the 37. Okay. So in the RPM, rotation per minute, so we try to control about 150 degrees C, but slightly you see now is 152 RPM, right? And then the air coming into the bioreactor, because we want to control just only the flow rate of the air. You know, the air is containing about the O2 21%, and the nitrogen what do you call this, how about 70%, something like that. Is that right? No. And then the because the airflow we just you know, to control is slow liter per minute, so around 0.5 liter per minute. So here, but still not coming in. Yeah, we try to you can press this button. Okay, alright, you can see here you put auto, right? And the setting now is 0.5 liter per minute RPM, right? So I think this maybe after this you can discuss. If you have some problem running bioreactor, you can ask our very good experienced technician, Brother Anwar and Brother Azlan. Is that right? But today I just showing you how we can set up this the gas flow inside. The gas flow, please you remember the gas flow just we are using air. Yeah, not this maybe CO2, not using pure oxygen. We just using air. Air is being containing about 21% oxygen, and then the rest of nitrogen. So the air actually a very good system to enough provide this what do you call our E.coli condition. And then you can see here it's very fast. Within maybe how many minutes already, but they're still growing. Yeah, they have some bubble. You can see the bubble here. is the bubble is mean they stand for because this they have a lot of proteins inside, and then they have the spudging to make sure the mixing, the homogeneous system. That's why you have the spudging, you have the agitation. So we need to provide enough this mixing the homogeneous system. Once the good homogeneous system, and then inshallah our culture E.coli they can grow better. Okay, that's all. Any question that you want to ask me? Apalah dekat. So now the time actually I want to see about the growing our cell inside in the bioreactor. So you need to confirm if you want to confirm the growing of the cell inside the bioreactor. So we want to take the sample either maybe 15 minutes, 30 minutes, 1 hour, depend how fast is it the E. coli growing inside. Okay, so now we want to take our sample every 30 minutes. Alright, so I want to show you. And then it's very easy to take the sample, and then I try to open the tubing because this inside they have some pressure, right? So they have some pressure. I open the tubing, and then you can see here I just make open slightly, and then they have some pressure inside, right? You see now? So very easy to collect the sample about the 15 ml or 20 ml. Alright, so I will stop here. Okay, now I stop here. I try to clamp again here, right? Okay. So make sure there is no pressure here, right? And I try to open this and make sure there is no leaking, because your microbe is a very dangerous microbe, especially maybe I don't know, maybe as Dr. Sakina put it, this what they call this strain is from recombinant E. coli, right? Okay, I try to open this slightly, just okay. Yeah, Brother Anwar can help me please. And then now I try to transfer into the Scott bottle, just about the 15 ml. Okay, alright. I try to close it, and then you can keep it this sample, and then you put in the storage is maybe you can put is minus 20 or 4 degree. If you want to measure determine the OD. You can put this maybe in the 4 degree, and then after that you can read into the UV. Okay, alright. So this one is still growing. Maybe I can say 0.2, 0.3 the OD. Yeah, so make sure. Yeah. So if you want to measure this, they have 3. Maybe they want to determine this growing of cell. First, maybe total cell number. You can put is the Itoma counting chamber, is that right? And the second one you measure with the OD, optical density, the wavelengths maybe 610 nanometer, and then the other one cell gravity. Yeah? So we can discuss later about cell gravity, and then how you can operate the what they call the centrifuge, and then you can separate and the cell and the supernatant. Yeah? Supernatant without the cells, and then the pellet they have the some E. coli into the pellet. And then the pellet, maybe after that we try to disrupt the cell because our cell containing a lot of protein inside, alright? And then we can do what we call this process. The next step is the cell disruption using what we call this homogenizer, or maybe we call the bed what we call sonicator. Sorry, yeah, sonicator. So I think that's all for the sampling. Habis, done.
Okay, after 30 minutes, we take out the sample, we put in the centrifuge tube. Okay, what we did now, we want to read the OD or optical density using the spectrum. Firstly, you need to have 2 cuvette. Okay, the first cuvette is your blank. The blank is media we use the blank media. Your blank is your empty media, okay? And your another cuvette is for your sample. So what you did, you pipette 1 ml because we use the cuvette 1 ml. Okay, you pipette 1 ml. Okay, this is the media. And
Oh, this is 3 ml ml and 3 ml cubed.
you pakai clear.
Okay.
Okay. So three. So we put the sample to 3. Because we use the large one, this is 3 ml cuvette, so we need to put 3 ml sample inside. Okay. Then we bring the sample to the spectrometer. Okay, switch on the spectrum first. Okay. Normally it will take time to initiate, so just wait. Boleh cubet baru.
Holder.
Ada dia.
Single holder.
Bawah ni ada lagi kan spektrum. Betul yang tak ambil. Ada satu kan spektrum bawah. Sekali ada sampel. Kat dulu.
Kejap je.
Okay. Okay, then after it's already done, we choose absorbent. Okay, so this one and start. Okay, firstly you see that the wavelength is not the one that we want. So what you did, choose this one. Wavelength, we set the new wavelength which is for the to know the cell growth. We use 600 nanometer. So you see it's already changed to 600 nanometer. So firstly they instruct us to measure the zero first. So this is our zero, the blank media, the empty one. Okay, you see it's clear. You clean or wipe the cuvette at the empty space, that one. Okay, then what you did, you put inside. Okay, and you click zero. Okay. Okay, then they ask us to start the measurement, so take out the blank. Okay, similar one, you see this is your sample. Okay, wipe out the area, and then this one just start. Okay, measuring. No okay, so this is your absorbent, which is 1.277. Okay, so you similar thing if you did for protein or sugar. you need to use the blend, which is for protein and sugar. We use the distilled water and then your sample.